What is the maximum number of electrons that can be placed in the sixth shell? Alright, we're talking about electron configurations here. And remember, we're not talking about a certain orbital. We're talking about an entire shell, the sixth shell. Just to refresh our memory a little bit. First shell, what do we have? Well, we have an s orbital. And it can take a maximum of 2 electrons. Because there's no other subshells, that's all the electrons you can put in the first shell. Second shell, we have s orbital and p orbital. Each p orbital can take up to, because of its 3 individual orbitals, up to 6 electrons. And then third shell, we also have now 3s, 3p, and 3d. Despite the energy difference between 3d and full s, well, 3d still belongs to the third shell. So 2, p orbital still 6, d orbital have 5 individual orbitals and can accommodate up to 10 electrons. Fourth shell, now we have s, p, d, f. 2, 6, 10. F orbital has 7 individual orbitals, and that's 14. Yep, maximum electrons. Fifth shell. 2, 6, 10, 14. Everything that fourth shell has, fifth shell has it. The fifth shell has more. It can accommodate imaginary g orbital, because we never really used it in our periodic table, but it doesn't mean that it wouldn't exist. If we go there, g orbital is supposed to have 9 individual orbitals and accommodate up to 18 electrons. And then now the sixth shell that we're talking about, s, p, d, f, g. If we're going to have a further subshell, let's just say it's h. Sixth shell would have it. And supposedly, as your quantum number change, your h orbital could have up to 11 different individual orbitals and can accommodate 22 electrons. So 1, 3, 5, 7, 9, 11, all odd numbers of orbitals, and double. Each orbital can take up to 2 electrons, the Hans rule, and double the electron amount. And if you add them up, you got the answer that you want. First shell, so total electron, or max number of electron that you can accommodate. First shell, just 2. Second shell, 2 plus 6, 8. Third shell, 2 plus 6 plus 10, 18. First shell, 2 plus 6 plus 10 plus 14, 32. Fifth shell, plus 18, 50. And sixth shell plus 22, 72. So that's how we figured this, each individual shells, how many electrons maximum can it accommodate. Now, does that mean if I'm asked, let's say, 10th shell, I need to do this entire setup of calculation? Not necessarily. Looking from the results here, we can actually generalize some kind of rule that we can apply very easily. Now, these numbers are all 2 times the square of your primary quantum number, the shell number. As you can see, first shell is 2 times 1 square, that's 2. Second shell is 2 times 2 square, that's 8. 2 times 3 square is 18. 2 times 4 square is 32. 2 times 5 square is 50. And 2 times 6 square is 72. So if you're asked, let's say, what's the maximum number of electrons the 11th shell could accommodate, then you can very simply do the calculation by going 2 times 11 square, so 2 times 121, that's 242 electrons accommodated. Just the example. Now, the answer, of course, for this particular problem is that in the 6th shell, it can accommodate up to 72 electrons.